First half is resonance, second half is two-port networks. First I will take up resonance. Yes, tell me. Now coming to resonance, series resonance, parallel resonance is there. Series resonance, parallel resonance. And in series resonance, quality factor, you can take it 1 by R root L by C. In parallel resonance, it is XL by R. This quality factor is otherwise called as sensitivity or quality factor. Okay, almost the same. Next, the resonant frequency. In series resonant, it is 1 by 2 pi root LC. In parallel resonance, it is 1 by 2 pi root LC square root of L square minus L by C, R square minus L by C. Okay, you can see this circuit. Whenever a circuit is given, you write the Z, equate imaginary part to 0, you will get the resonant frequency. Equate imaginary part to 0, you will get the resonant frequency. Okay, just I will write a few things for resonance. For resonance, I am going with resonance. We have two things, series resonance and parallel resonance. Series resonance and parallel resonance. Okay, and FR, resonant frequency, is 1 by 2 pi root LC. Here resonant frequency is 1 by 2 pi root LC square root of RL square minus L by C, okay, divided by RC square minus L by C. I showed you the equation. I will check afterwards. Now coming to the quality factor or selectivity. Okay, quality factor or selectivity in series resonance, it is 1 by R root L by C you can take. And selectivity in parallel resonance, it is XL by R you can take. Here you can take one more formula, resonant frequency by bandwidth is also allowed. Based on these formulas you will get the problem. Series resonance means you will have R, L, C. Okay, R, L and C. If values are given, this is the supply voltage. For example, this is 10 ohms. This is J into 5 and this is minus J into 10. Okay, minus J into 10. Supply voltage is given. Z value is R plus JX. X is because of inductor and capacitor. Okay, plus J into 5 minus 10. This is Z value. Generally you take the imaginary part and equate it to 0, where you will get the resonant frequency. In parallel we have three types. Okay, in parallel we have three types of circuits. So one is you may have R with the inductor and R with the capacitor. Okay, this is one model, parallel resonant circuit. This is R and L, this is R and C. Okay, another model you may have only L and C. This is second type, L and C. And in the third model you may have R value and then L value and then C value. Okay, this is third model circuit, R, L and C. These are the three types of parallel resonant circuits. And you have the formulas also. Okay, for calculating resonant frequency, and then for calculating resonant frequency, and then for the quality factor. Okay, and then for the quality factor. Very easy. I will just show you one or two problems, and resonance I will close. This is parallel resonance. You can see R and L is present and C alone is present. Find the resonant frequency means you have tried the Z value. Okay, or you take the formula in parallel resonance. In the place of RC you put 0. In the place of this RC you put 0 in the denominator, and you appropriately make it. Okay, appropriately make it. And then anybody message me who is doing this. Now coming to Coming to RC, you will put it 0. Coming to RC, you will put it 0 in the formula, and appropriately you calculate as per the formula. Okay. And this is another problem here. RC is not there. You have to put 0. And then this you can see, this is again one general formula, very important formula. Okay. This is again one important formula which you can use for all the circuits in parallel resonance. All the circuits in parallel resonance, you can just use it for calculating whichever value. If RL is not there, RC is not there, L value not there, C value not there, this formula will give you the answer. Okay. So all these models we have done in the class notebook. You apply any of this, you know XL means omega into L, omega means 2 pi F. In the circuit, F value will be given. If units are radians per second, directly the given value is 4000 omega value. Given value is omega value. Okay. If the units are hertz, if the units are hertz, then it is F value. You should be very cautious. The frequency, if it is radians per second, then the value given frequency is omega value. If the units are hertz, then the frequency is F. Okay. You know X means omega into. Okay. And then RL, RC, you know, which is along with the L, that is RL, which is along with C, that is RC. These are the formulas you have to remember in resonance. In resonance. Next I am going with in resonance only this much. Other curves you have, other things you have. These are the reactance curves. These are the reactance curves. You can see parallel resonance reactance curves are there, and then series resonance reactance curves are there. Okay, series resonance. I will put all this in the PPT and give you the PPT also in one stretch. Okay, if they are asking all the series resonance curves, you draw the curves, and parallel resonance, you draw the curves. Equations, what I told you now, we discussed now. Okay, we discussed now. You can just remember them and use them for problem solving. Okay. With this, I am closing resonance. Next, I am going with two-port networks. I am going with two-port networks.